All right. Hey class. This is the last video before Tuesday's quiz. This one's all about word problems. I'll do my best to help you go through. So the first thing you have to do, of course, is read the thing. Read it and make sure you really understand it. But it says a sledding run is 800 yards long with a vertical drop of 27.6 yards. Find the angle of depression of the run. Okay, guess I will. Let me turn off this calculator. Move my other calculator. Back to over there. Okay, I'm ready. So the sledding run, you can imagine sort of ground. Then you can imagine a hill. A sledding run is just a hill that you come sledding down. The 27.6 yards is going to be this distance that's measured vertically straight down from the top of the sledding run. So this dimension here is your 27.6. Yes, we can assume that this is on a right angle. You always measure things on a right angle. And finally, we've got the 300-yard long sledding run. Somebody's going to put the 300 down here. This is not what they mean by 300 long. They mean your trip down the hill is 300 units long. Big difference in where you put that. So you have to make sure that you just can read it and make sense of it. You have to understand. So what are we solving for? Said we wanted to find the angle of depression. Well, the angle of depression would be measured from the top of the hill. You draw a line that points straight out like east-west. An angle of depression would be this angle that measures down to the hypotenuse. Well, if that's my theta, it might make a little more sense to just say that if this is theta, this is theta, because those are alternate interior angles. And this angle is just the angle of elevation. And if you don't remember much about angles of elevation and angles of depression, at least remember that they're always congruent to each other. So if the question asks for the angle of depression, just find the angle of elevation instead. They're going to be the same thing. And the drawing makes a little more sense, usually, when you're talking about an angle of elevation. So anyway, let's set this up and solve. I see I'm working with the opposite side and the hypotenuse. So opposite and hypotenuse is not tangent, it's sine. So we'll say the sine of the angle that we don't know, theta, is equal to 27.6 over 300. So how do you do this? Well, you take the inverse sine of both sides, we said. If I do inverse sine, then the inverse sine and the sine will cancel, I'll get theta. On the other side, I'll get the inverse sine of whatever this is. All right, so let's now find out what theta is. The easy way, the medium way, and the hard way. The easy way first, of course, is just having your calculator, a TI graphing calculator. Because if you got that, you type it the way it looks. You say inverse sine 27.6 divided by, ooh, nothing's working. I'm clicking in the wrong place. I'm sorry. Inverse sine right here. Inverse sine 27.6 divided by 300. Yeah, there you go. So the answer is 5.28, which seems really small, but it isn't. Now why isn't that small? Well, because think about it like this. They gave us this sledding run, and they told us the drop is 27.6. It sounds good. Then they told you the run was 300. 300 is way longer than 27. So if we were going to draw this more honestly, it would be like this. Like way the heck out to here. And so now look at our angle. It's tiny, right? The 5 degrees should actually seem normal. It should seem like that's exactly the right amount. If you got something like 20, that would seem too big, wouldn't it? So don't freak out that 5 degrees doesn't seem like a real answer. It's real. We can think it through. It makes sense. let's move on. So the next problem is talking about a doctor who is using a treadmill. Let me get rid of the TI calculator. That actually reminds me, I said I was going to do it the other way, so I'm going to keep my word on that. How do I get rid of this? Alright, goodbye TI. And let's go back. So how do we find this angle on our other calculators? If you got a scientific, then you have to actually do the 27.6 first. 27.6 divided by 300. That's going to get you a decimal on your screen. With that decimal on your screen, to do inverse sign, you hit second, and then make sure you get inverse sign. And there's your 5.28. So the same answer, just slightly different keystrokes. And of course, last but not least, if you only have a 4-function calculator, then you can still type in 27.6 divided by 300. See what it is. What the heck? Hold on, I'm going to do that again. I don't know what that means. So I'm going to do that on a real calculator. Seems like my calculator is bugging out. Is it because I'm in second? If I turn that off. I'll try one more time. 27.6. Yeah, that makes more sense. Alright, so what do we do now? If you've only got a 4-function calculator, then you can get this decimal, and what you got to do, of course, is go back to your table. But this time you're looking for that 0.092. And because it came from sine, it's a sine problem we're doing? Yeah, so you're looking through the sine column, trying to find your 0.92. So starting here, there it is. It'll be right there. It'll be right between 0.8 and 1.0. So you'd call it 5-ish, right? There's no better answer. If you only have a table to use, then you're going to give me your answer as theta equals somewhere between 5 and 6 degrees. If you gave me that, it's fine. I'm giving you full credit. Obviously, what I'm looking for is 5.28. I want to see, a pretty good specific answer. All right. So now we can move on to number 2. This one says a doctor is using a treadmill. So treadmill, as you all know, is a little belt like this. And that's going to be up off the ground. Down here's the ground. We can assume a treadmill makes a 90-degree angle with the ground. So, treadmill. Up here, there's a little screen. You can watch what you want to watch. You all know what treadmills look like. So there's my picture of a treadmill. It's not very good. What do we know? They told us the treadmill was 48 inches. 48 inches to me then is this dimension. The treadmill is the part that you run on. So this length, I'm sure, is what they meant to be 48. It says he sets the 48-inch long treadmill at an incline of 10 degrees. 10-degree incline would mean this angle measure is 10 degrees. So it says how high is the end of the treadmill. So we're solving for this dimension down here, which I'll call h for height. Then you write an equation, you solve it. So I'm working with opposite and hypotenuse. So this is another sine equation. We'll say sine of 10 equals h over 48. And that's going to mean that h is sine of 10 times 48. All right, so what's that going to be worth? 48 times 10 sine of 10 equals 8.34. And since these are inches, these have to be inches too. That's 2. So for 3, It says find the angle of elevation of the sun when a 12.5 meter tall tower casts an 18 meter long shadow. Okay, fine. So here's my tower. I'll make it one of these guys. That's a pretty good tower. Now, here's the ground. So here's the deal. If I'm a shadow, then I fall down like this, and I get cast down here on the ground, and apparently it's taller, so it must be late in the afternoon, and it would be, I don't know, more see-through-y. There you go. How's that for a picture? Pretty good, right? Now you can imagine a line connecting the top of the tower down to the tip of the shadow. You can also imagine that the tower forms a 90-degree angle with the ground. So there's our right triangle. And we can label what we read. We're reading, find the angle of elevation. Okay, that's easy. That's the angle that rotates up from the ground. So that'll be our theta. Then it says, when a 12.5 meter tall telephone pole. So that's this. Oh, I didn't realize it was a telephone pole. This is a badly drawn telephone pole, but that's okay. Casts an 18 meter long shadow. So down here, the shadow is 18 meters. Now that you've got your picture drawn, the rest should be cake, because we can look and see that 12.5 is opposite from us, and the 18 is adjacent to us. So we're writing a tangent equation. It's going to be the 12.5 in the numerator divided by 18 in the denominator. So how do I evaluate this? Okay, so we'll just figure out what is 12.5 divided by 18. So it's this decimal. We could look that decimal up on our table to get our angle measure, or we can just hit second and choose inverse tangent of that, and we're done. It's going to be a 34.78 degree angle. Why? Because from here we always have to do inverse tangent. It's going to be the inverse tangent of this fraction, which was what? 0.6944444? Oh, shoot. Oh, because it's supposed to be tangent. My bad. Alright, so 12.5 over 18. Yeah, 4444. That's what I thought. So that's what we're doing. We're just doing the inverse tangent of 0.6944. And I forget what that gives us. 34.78. Don't forget your units. These are meters. So these are meters too. Alright, number 4. It says a person in a hot air balloon. Alright, so we got grass, grass, grass. Got a hot air balloon up here. We got a little basket down here. Alright, it's pretty good. We got car. It's over here. It's a pretty good car. Alright, what do we know? It says a person in a hot air balloon is looking down with an angle of depression of 36 degrees. So that would mean that if I drew a line from the basket, that's where the person is, down to their car. Then if I drew a line that was perfectly horizontal, like this, then that angle is where I'll find the angle of depression, which is 36. So there's your angle of depression. What else do we know? It says their car is 75 feet away. It's a straight line distance though. So from the person straight to their car is 75 feet. So it says, how high is the balloon? Well, how high is the balloon? You'd usually measure here, yeah? But you could kick that over here. And this is the same height, of course. And we could work with this triangle. And maybe it feels upside down to you. If it does, that's fine. But we want to find this height, which is the same as this height. We know the angle of depression being 36 means the angle of elevation was also 36. So I don't care which of these triangles you look at. You can look at the triangle that's here sitting on the ground, or you can look at the one that's here, kind of floating in the air. They have the same information. Doesn't matter which one you solve. So let's see. 36 makes h opposite, and this is hypotenuse. That sounds like a sine equation to me. So it'll be the sine of 36, and it'll equal h over 75. So the height of the balloon is going to be whatever 75 times the sine of 36 is. So let's find out. All right, 75 times 36 sine equals 44.08 feet. Okay, number 5. This one says, a student wants to know how tall the flagpole at her school is, and this one is a little trickier than most. Alright, I'll do what I normally do. Here's the grass. Here's a flagpole. Okay. Then the weird part is it says her eye level is 5.5 feet above the ground. So we draw her. And we have to mark her eye level. So the triangle that we're considering right now is really this one. And we can say that that's a right angle. What else can we say? She stands 36 feet from the base of the flagpole, so technically this distance is 36. But I hope it's obvious that this would also be 36, this part of the triangle. It says the angle of elevation from her eye up to the flagpole is 25, so this is 25 degrees. So the weird part happens now. It says, what's the height of the flagpole? Well, right now, all I can find is this. The height that goes down and stops here at eye level. Luckily, we already know this bit right here. It was given to us. Her eye level was 5.5 feet up, right? So if we carry that over, then to find the total height, we're going to find h, which is only a piece of the flagpole, but the other piece we know to be 5.5. So our final answer will be what those measurements add up to. So taking everything, 25 makes h opposite. This 25 says this 36 is adjacent. So we're writing a tangent equation. The tangent of 25 will equal h over 36. And we'll get that answer by cross multiplying. So do our calculator. We want 36 times tangent of 25. So we go to 25 tangent, then we go equals, and I'm getting 16.79. But that's not the end, because don't forget the actual height of the flagpole is going to be this answer, 16.79 plus the extra 5.5, which is going to give us what? 23.29? I think that's right. I'm going to use the calculator just in case. Oh, so just add 5.5 to this. 22.29. That's what I said. So I screwed it up. How did I screw that up? I don't know. I think I got ahead of myself. I think I carried the 1 twice. This should be 22. Sorry about that. Alright, so these are all feet. So this is feet. Moving on. Number 6. It says a person whose a person whose eyes are 5 feet above the ground is standing on the runway of an airport, 100 feet from the control tower. That person observes an air traffic controller at the window of the 132-foot tower. What's the angle of elevation? Okay. So air traffic control tower looks something like this. It says a person whose eyes are 5 feet above the ground is standing. The tower is 132. So if the person is standing 100 feet away, and they want the angle of elevation. This question is written pretty badly, actually, because if it says, what's the angle of elevation, I'm asking from where to where, because the potential answers here are from eye level to the air traffic controller in the tower. Or is it like from the ground? And it's not from the ground. That wouldn't make sense. So I would be measuring from this guy's eye, which means we'd have to draw in this horizontal again, draw a line up to the air traffic controller in a window. Here's my right triangle. So what changes? This will be 100. This angle here, the angle of elevation, is the angle we're trying to solve for. And then the thing that changes is, yeah, the tower is 132 feet tall, but down here we've already used up 5 of it. So take away 5 feet from this, and you get a new height of 127. So to solve this problem, you're using the 127, 100, and theta. So that's going to give us tangent. Tangent of theta is going to be the 127 over 100. Which means theta is going to be the inverse tangent. I want to just get that out of the way. What's 127 over 100, you might ask? .27, of course. We should know those rules, by the way. I'm punching the numbers, but dividing by 100 just brings the decimal point over, makes it 1.27, right? Figured I'd show you on the calculator anyway. But if we're looking up 1.27, then theta must be approximately, and I'm going to take you to the table for this one, 1.27. Okay, let's find it. 1.27, and looking in the tangent column, so it's over here. There it is, 1.2799. So we must be between 51 and 52. Ay, ay, ay. So again, you'd write it like this. You'd give me the two angles and just indicate that it's somewhere between there. So what's the real deal? $51.78. That's it for 6. And how many more of these are there? Because I'm getting tired. 6, 7, 8, 9, 10. I can do 4, I guess. All right, so 7 says, I think this is a weird one too. A golfer is standing at the tee. All right, so let's say the tee is a flat ground. But he's looking up to the green on a hill. So actually, it goes up, 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 and then here's the green. If the tee is 36 yards lower than the green and the angle of elevation from the tee to the hole is 12. All right, so whatever. Let's call this the tee. We'll call this the green. I'm just going to rough everything in. It's not perfect. But what they're trying to imply is that the vertical change down from the green to the tee zone is the 36 yards. So that's this dimension. They're saying that the angle of elevation is 12, so that's this angle. And it says find the distance from the tee to the hole. So the distance would be the actual hypotenuse, that total thing there. I'll call that D for distance. So how do I solve? Well, we're working with opposite and hypotenuse. So you know you're writing a sine equation. So it's opposite over hypotenuse. And we can use that little trick again where we know these entries can just flip. So we can say D is equal to 36 divided by sine 12. And let's go see what that is on our calculator. So we go 36 divided by 12. Sine of 12. It equals 173.15. These are yards. All right, again, does an answer that big make sense? I'm saying yes. Why am I saying yes? Well, because 12 degrees is a very short angle. So the further out you go, the longer that hypotenuse is getting. So if with a very small angle, that hypotenuse is going to be stretched pretty long. So I trust this answer. I don't find anything weird about it. Let's do 8. A ladder leaning against a building. Okay, pretty classic. Here's my building. Not my best. But it makes an angle of 78 degrees with the ground. So the ladder comes down and makes a pretty steep angle with the ground. So this angle right here is 78. What else do we know? The foot of the ladder is 5 feet from the building. So that means this dimension is only 5. It says how long is the ladder? So what we're solving for is this. Let's just call it X. I don't like L as a variable. So long, ladder, I'm not using L. So what do we got? The building is opposite. So that's out. So the 5 is adjacent. That's in. And X is our hypotenuse. So with adjacent and hypotenuse, we're going to write a cosine equation. Cosine is the Ka, C-A-H. And so Ka Toa. Since we have A and H, we know that's what we want. So we'll go cosine of the 78 equals 5 over X. And again, just cross multiply. Throw this over 1 if you want to, but essentially just these two are flipping. So you'll get X equals 5 divided by cosine 78. And our calculators will do the work. So it's 5 divided by 78 cosine equals 24.05. Feet. Okay, that's 8. 9. A person is sitting on a 30-foot pier overlooking the ocean. Okay. Here's my pier. Put some legs on it. Put one in the middle. Keep everybody safe. Alright. So there's water down here. Glug, glug, glug. So here's what isn't totally clear. When they say 30 feet, do they mean the length of the pier? They could, but I'm sure they don't. I think they mean the height. So I wish they had made that a little clearer, but you can trust me. 30 feet is how high above the water this pier is. That's what they're going for. Now it says his angle of depression to the whale. I guess there's a whale out here. So, can I draw a whale? That a good whale? Seems pretty good. Have them spouting some water. Alright, good whale. Great whale. So what do we know? Angle of depression down to the whale. Again, the angle of depression would actually be this angle that we measured downwards from horizontal. So if that angle is 20 degrees, well then the angle of elevation is 20 degrees. I can't think of a time when you'd really rather use the angle of depression. If you can use the angle of elevation, just do it. But it's asking us how far is the whale from his eyes. So instead of measuring across the ocean, measure from the dude's eyeballs down to the whale. And I didn't pay attention to this part, did I? His 3 feet above the pier. Rats. Okay, so what does that mean? That means this guy's actually standing up here on the pier. And there's his eye. That adds an extra 3 feet. So in my triangle, we should call this total height 33. And that makes this a little steeper. It's the same 20 though. 20 is right, 30 is wrong. We're using 33. And we're solving for this distance, d, down the hypotenuse. I just blanked on the word hypotenuse. Alright, we've only got a couple more. I can do this, but I am getting tired. Alright, so what do we got? Opposite from the 20 is the 33. That's opposite. D is the hypotenuse. So we're doing a sine equation. So the 20 degrees is fine. The 30 was not fine because it's 30 feet up to the dock, but then it's 3 more feet up to the person's eyeballs. So that means we got to use the 33. And we'll divide it by the distance to the whale, which is d. So cross multiply, however you want to think about it, but we know that our answer is going to be whatever 33 divided by the sine of 20 is. So let's go find out. 33 divided by 20 degrees, sine of that equals 96.49. Okay, that's the whale problem. Lastly, 10 is last, right? Okay, great. So it says, after flying at an altitude of 500, a helicopter starts to descend. Window, door, rotors, other rotors. Not my best helicopter. I can live with it. So after flying at an altitude of 500 meters, okay, helicopter starts to descend when its ground distance from the landing pad is 11 kilometers. Okay, landing pad's over here. There's a little landing pad. So here's the thing, they're messing with you a little bit. It says 11 kilometers and 500 meters. So we got to make these agree. So there's 100 meters in every kilometer? I don't know. I'm pretty sure that's right, but I'm going to double check everything. So 11 kilometers to meters. I think Google will translate that. You just literally ask it to. Oh, you can't really see much. That's okay. Yeah, whatever. It's converting to miles, meters. Yeah, it is 1,000. That's what I was afraid of. Okay, so it's not 100, it's actually 1,000. That changes things a lot. So that means the distance down here is 11,000 meters. So that means this dimension is tiny compared to this. So my drawing is really off the mark. If you were going to try to draw this, it would be like a teeny tiny vertical change and a super long horizontal change. So this drawing might be more accurate. I'm just going to stick with this though and hope that you guys are with me. It says, what's the angle of depression? So the angle of depression, if you just want to draw it correctly, is this angle. But we're just going to find this angle again like usual. And hopefully you see this is a tangent problem. So we'll say the tangent of theta is the 500 divided by the 11,000. That's going to be a tiny fraction. Let's go see what it is. .04545. And that repeats. So do the inverse tangent. See what we get. Should be teeny tiny. It's only 2.6 degrees, 2.60 degrees. All right, again, if you're looking at this picture, then no, this answer makes no sense. But if you're looking at this picture, we've got 500 as a small little vertical change compared to 11,000 as a super long horizontal change, then having this be only 2 degrees, that makes sense. That feels right. Don't freak out about it. Anyway, that's 10. I think we're done. So, thanks for watching. I hope it helped, and I hope you do great on Tuesday's quiz. See you then. Bye.